Queue and priority queue, ordered processing. A queue is a collection designed for holding elements prior to processing. The classic queue follows FIFO, first in, first out, like a line at a coffee shop. So priority queue breaks this rule by serving elements based on priority, not arrival time. And this one is same like comparable, comparator. Okay, we have seen these kind of things so many times. So first queue interface. Queue defines 6 core methods into flavors. So add, offer, we have seen this differentiation, remove, poll, and element and peak. Okay. So these one will throw exception and these one will no. Okay. So prefer the safe methods. And if you have to exit or if you want to know at exact time that you got something, and if you want to stop your process, then you can basically go with this. In most cases, use this one. They handle edge cases gracefully by returning null or false instead of throwing exceptions. But usually we will prefer these kind of methods like safe operations all the time. Okay, so first one is basic queue with linked list. We can import this one. We have seen this one. Okay, so we will go first queue, then add elements, queue.offer, this one, third, then peak at front without removing. So queue.peak, then remove from front, queue.poll. Okay, so by default, this one is poll first. All right. So basically we are pointing this reference to our queue interface, and in that one we have some specific methods. So let's see if we have poll first or poll last. Let's see. What we can do is we can remove this one. We can then basically do this. We can remove these comments, but let's just say this. So if we compile this and if we run this, then that's fine. Queue.poll processed equals to queue.poll. So we have to print basically these things. But can we do something? So queue.poll, can we do something here? Poll first. No, we don't have that. Poll last. We don't have that either. But if we put here linked list, then we have this method. So you can see different interfaces designed so that you don't get confused. This one is queue, that means you will not get this one, poll last. Okay. By default, you will get poll, and that will work as poll first. All right. So that's how we can check sometimes if we don't remember. Now we can move forward with our queue visualization. That's fine. Offer A, this one, then B, okay, C. Now we have this one front, and poll, we will remove A, and peak, then we will return B, but no change in our queue. So same thing. Now priority queue, this one is very important. Priority based ordering. So priority queue doesn't follow FIFO. Instead, elements are ordered by priority, and that can be anything. So in this case, by default for alphabetical, we will do like basically sorting in ascending order. So if you offer 30, then 10, and then 20. But if you poll or if you print, then you will get 10 first, then 20, then 30. And we have seen this thing. Okay, now we have insertion order not equals to priority order. Iterating over a priority queue doesn't give elements in priority order. Only poll guarantees the priority ordering. Okay, this one is very important thing. The internal array representation isn't fully sorted. Okay. We can also check this thing, this one. Okay, let's see. So we can create here, and then now we can see something. Okay, we can add a little bit more. So pq.offer 50 and then 40. If you try to print here, system.out.println, not all, basically just pq. This time we will not get like sorted order. So you can see we got 10, 30, and basically that is also not insertion. Okay, so this one is random. The only way to get our sorted order is by using poll method, and we can do that by using something. So we can write here, while not this one, then we can print this. Basically, we can print here. Okay. We can compile this and we can just run this one. So this time you can see 10, 20, 30, and 40, and 50. So this one is very important thing. Now our next thing is Max-Heap, largest first. So by default or natural order, we are getting shortest first, right? Same case with our strings and other things. Okay. But what if we want largest first and we call that Max-Heap? So we have to put here, or we have to pass, or we have to tell, okay, that we want this order. Then we have this one, comparator dot reverse order. So if we add this one, but if we now poll, then we will get 30 and this order. Okay. If you have your own class, then you can do this with comparator and comparable as well. Okay. So new priority, comparator dot comparing int task dot priority. Okay. Now multiple sort criteria we can chain by using dot then comparing, and we have seen this method. All right, we will not see that again. So our priority queue is also tree type structure. All right, if we have Min-Heap, that one is the by default. Then our at root node we will get shortest value. Okay, and then for Max-Heap at root node we will get largest value. That's fine. Normal things, you know already. And also we don't have to interact with those kind of structures. We can interact with these methods. Okay. And when we poll, then our internal that tree structure will reorder itself. Okay. Now we can move forward. Multiple sort criteria. That's fine. Priority queue operations. First one pick. All right. That's fine. Then size is empty. Same things. Contains. Then remove. We can remove by key. Okay. Remove if. Remove all matching. Clear everything. Now performance characteristics. So first one is offer, login, nodes heap, insertion, then poll also heap, extraction, then pick O1 because we don't have to iterate or look anything. We just have to remove our first node. So just returns root, contains ON, okay, linear search, then remove object, ON, find plus fix. Okay. So we have some use cases. First one is task scheduling. So record, we know records, right? So you can do that. Scheduler.offer, process task in scheduled order. That's fine. Now finding k largest, smallest element, something kind of data structures algorithms. Merge k sorted list. Okay, totally fine. Add first element from each sorted list with in list index. Extract min, add next from same list. Okay, so that's fine. We will not see these algorithms here. You can read from here documentation, that's fine. Now queue versus priority queue, order FIFO by priority, then offer O1 log n, all O1 log n, null elements allowed. In sorting we never allow. Okay, so not allowed. Use case, BFS, buffering, scheduling, top K problem, something like that. But we have many more. Then we have quick summary and we can move forward with our next chapter, which is DQ and array DQ. So we have seen here queue interface basically. Okay. And this time we will see DQ interface or array DQ.